Imagine trying to learn a complex subject, like a new language, purely by memorizing every single sentence you hear. You would quickly become overwhelmed and unable to form new sentences or understand variations. Similarly, machine learning models face a significant challenge: how to learn general rules from limited data without simply memorizing it. Yes, absolutely. Inductive bias is a crucial mechanism that helps prevent machine learning models from overfitting. It acts as a guiding principle, enabling models to generalize effectively from the training data to unseen examples. At its core, inductive bias refers to the assumptions an algorithm makes to learn a target function. Without these assumptions, a model would have infinite ways to interpret the training data, many of which would just be memorization, leading to poor performance on new data. This bias helps by narrowing down the hypothesis space, which is the set of all possible explanations the model could generate. By making reasonable assumptions about the nature of the data and its underlying patterns, the algorithm avoids the pitfall of learning noise or irrelevant details from the training set, directly addressing the bias-variance trade-off by reducing variance. Understanding and leveraging inductive bias is highly practical. When selecting an algorithm, you are implicitly choosing an inductive bias. For instance, linear regression assumes a linear relationship between features and the target variable. A convolutional neural network, or CNN, designed for image recognition, incorporates the inductive bias that spatial locality and translation invariance are important features. By matching the algorithm's inherent assumptions to the known structure or properties of your specific problem and data, you equip the model with powerful knowledge before it even sees the data. Consider the no-free-lunch theorem in machine learning, which states that no single algorithm is inherently superior across all possible problems. This theorem underscores the importance of inductive bias. Choosing an algorithm with an appropriate inductive bias for your problem domain is not about finding the best algorithm overall, but the best fit for your particular data. It is about embedding common sense or domain-specific knowledge directly into the learning process, which is a powerful way to manage model complexity and enhance generalization capabilities. In essence, inductive bias empowers machine learning models to learn robustly by making informed assumptions. It guides them away from simply memorizing training examples and towards discovering genuine, underlying patterns. This strategic application of bias helps build models that are not only accurate on the data they have seen but also perform reliably and predictably on the data they encounter in the real world.